Hey there, Mr. Sutton here, bringing you the Algebra 2 2-2 Part 2 homework solutions on characteristics of quadratic functions, specifically dealing with intercept form. For this problem, we're trying to graph this y function here. Since this is in intercept form, we're going to start by getting the x-intercepts, which we just have to zero out each of these parentheses. So for this first one, we're ending up with -3, and for the next one, we have +3 for my x-intercepts. So that gives me 2 points I can put on my graph. Now to get the vertex, I just have to take the average of these x-intercepts. So that's going to be -3 plus 3 over 2. That's just 0 over 2, which is just 0. And that's the x value of the vertex. To get the y value, I just plug it back into the original function. So we've got 0 plus 3 and 0 minus 3. That's just 3 times -3, which comes out to -9, giving me a vertex of 0, -9. All right, let's graph all this. Let me do the x-intercepts first. So we've got -3 right here and +3. And then we had 0, -9 down here. And I can draw a parabola through those 3 points. To graph this quadratic function that's in intercept form, let me start by getting the x-intercepts. In this case, we've got -1 for this first parentheses and +3 for the next one. It's just whatever zeroes those out. And to get the vertex, I just have to average the x-intercepts together, and that'll at least get me the axis of symmetry. So we have -1 plus 3 over 2, just averaging these. That's 2 over 2, or 1. Now to get the y value of the vertex, I need to plug 1 back in for my original function. So we have 1 plus 1 and 1 minus 3. That's going to be 2 times -2, which is -4, giving me a vertex of 1, -4. So let's graph all of this now. We have our x-intercepts at -1 and 3, and then halfway between those at 1, -4, we've got the vertex. And then I'll just draw a parabola through those 3 points. To graph the y function here, since this is in intercept form, I'm going to find the x-intercepts, and then I'll just average those together to get the vertex. So for this first parentheses, my x-intercept is going to be -2. It's whatever zeroes these out. And then -6 for the next one. So averaging these together, we have -2 plus -6 over 2. That's -8 over 2, which is -4. And to get the y value of the vertex, because I just got the x value, I'm going to plug -4 back into this y function up here. So I have 3, and then -4 plus 2, and -4 plus 6. So that's 3 times -2, which is -6, times +2 is going to give me -12. So we have a vertex then of -4, -12. And now I have enough information to do the graph. So I have my x-intercepts at, let's see here, we had -6 and -2. So -6 right there and -2 right there. And then halfway between those at -4, -12. And I had to make my grid lines go by 2's to fit this on here. There's our vertex. And then just draw the parabola through those points. To graph the g function here, since this is in intercept form, I can start by finding the x-intercepts, and that will quickly give me 2 points. So we have an x-intercept for this -x part here of 0. We're just trying to zero out each of the factors. And then this x plus 6 gives me an x-intercept of -6. To get the x value of the vertex, I just have to average these two x-intercepts together. So that's 0 plus -6 over 2. That's just -6 over 2, or -3. Now, if I want to get the y value of the vertex, and I do want to get it, I'm going to have to plug -3 back in for x up in the g function here. So that's -3 out there, which is +3. And -3 plus 6 gives me another +3 here. So 3 times 3 comes out to 9. That gives me a vertex then of -3, 9. Let's put all that on the graph. So we have an x-intercept of -6 and one of 0. So here's -6 and here's 0. It's also a y-intercept. And then we had the vertex at -3, 9, all the way up there. And then we just draw a parabola through those 3 points. For this real-life problem, we have a passenger on a stranded lifeboat shooting a distress flare into the air. So the height of the flare in feet above the water as a function of time in seconds is given by this f function right here, -16t and t minus 8. So that'll tell us everything we want to know about the first flare. The second flare, they just modeled with this graph here. So we have the same kind of information just represented in 2 different ways. Based off of this stuff, we want to know which flare goes higher and which stays in the air longer. And why do we want to know that? Well, I don't know. I mean, we're stranded on this lifeboat. Nothing better to do. Let's just figure it out. So we already know everything we need to know about the height and the time in the air of that second flare, right? It goes up to 196 feet, and it takes 7 seconds before it hits the water again, before it reaches a height of 0. But for the first flare, we're going to have to find the x-intercepts, or I guess they'd be t-intercepts in this case. And also we want to find the max for this function as well. Compare it to this other max. All right, so for our t-intercepts, since this is an intercept form, we can just zero out each of these factors. To zero out -16t, I just plug in 0 for t. And then 8 will zero out this other factor here. So 0 and 8 are my t-intercepts. Now to find the t value of my vertex, I just have to average these 2 things together. So 0 plus 8 over 2. That's going to give me 4. And if I want to know, so this is the time at which we reach our maximum value for that first flare. To find the maximum height, we just have to plug 4 back into the f function right here. So I have 4 times 8, or 4 minus 8 rather, is -4. 4 times -4 is -16, and -16 times -16 gives us 256. Now 256 is higher than the 196, so that means that the first flare, which is what gave us this function, is going to go higher up than the second flare. Which one's in the air for longer? Well, intuitively, it seems like the higher one would stay in the air longer as well, but let's just double check. We have a t-intercept of 8 for that first flare. That means it takes 8 seconds for that first flare to hit the water. 8 is bigger than the 7 that we see in the graph here for the second flare. So the first flare is also in the air for longer.